Finding critical numbers means finding where the derivative equals 0 or doesn't exist. So let's first find find the derivative, right? So plus 2 sine of x equals 0. Then I'm going to solve for the sine of x. That gives me a negative 1/2. So between 0 and 2 pi, the x's are the angles, the x's that are, the sine is negative 1/2. I'm just going to draw the unit circle, is these two guys right here, right? So that's x equals 7 pi over 6 and 11 pi over 6. Okay, so that to find out when the function is increasing or decreasing, we could do one of two things. We could take and draw this function. So I'm just going to do both. So I can draw f prime of x. So I know this is 2 sine of x that shifted up by 1. So sine of x usually starts at 0, so it's going to start at 1, and it's going to go up and down and up like that, right? So the two x values that it crosses are going to be 7 pi over 6 and 11 pi over 6. So there's no guessing, right? Okay, so that's one way. Another way is that you could make a sign chart. 7 pi over 6, 11 pi over 6, and then we're going to check numbers in between. So when it's increasing is, I'm just going to use this graph here. When f of x is increasing, the f prime of x is bigger than 0. So that just means it's above the x-axis. And so when is this graph above the x-axis? Well, between 0 and 7 pi over 6, and then between 11 pi over 6 and 2 pi, right? So we can tell by looking at the graph of this. So if we were going to do it this way, we would just need to plug in numbers. And so you're allowed to plug in any number. So I can even plug in, like here, before 7 pi over 6 is pi, right? After 7 pi over 6 and before 11 pi over 6 is 3 pi over 2, and this would be 2 pi. So now we're plugging that into the derivative, right? So if I put pi into the derivative, I get a positive 1. If I plug in 3 pi over 2, sine of 3 pi over 2, you know, is negative 1. Negative 2 plus 1, that's a negative number. Oops, I'm trying to circle the positive sign. Didn't make sense there. And then if I plug in 2 pi, I get a positive. Okay, so when this, let me just make that a little neater. Okay, so this is a positive. So when looking at this, f of x is increasing when f prime of x is positive. So again, that would be from 0 to 7 pi over 6. Whoops, 7 pi over 6. And then from 11 pi over 6 to 2 pi. Sorry, that's really, my pen is not working so well. So let me try that again. 0 to 7 pi over 6, comma, 11 pi over 6 to 2 pi. Okay, so that's when it's increasing and decreasing. So now let's go and find out when the function has a extrema. Extrema means max or min, right? Oops, I shouldn't have erased the graph here, but I've got the sign chart, right? So the graph, let me just draw the graph again. Okay, and there was 7 pi over 6, and there was 11 pi over 6. Okay, so if I'm looking before and after the critical number, because that's how the first derivative test works, right? So I'm looking before 7 pi over 6, it's positive, right? Before 7 pi over 6 is positive. So y prime changes from positive to negative, right? Because after 7 pi over 6, it's negative. So therefore, the function must have gone from up to down, f of 7 pi over 6 is a local maximum. Okay, let's do the same thing for 11 pi over 6. So 11 pi over 6 is here. And so what you would want to make sure you say, let me make some room here. So you want to tell me that you're looking at the critical number of 11 pi over 6. So y prime changes from negative to positive. So therefore, f of 11 pi over 6 is a local minimum. Local minimum. So that explanation is necessary to show me that you understand what the first derivative test means.